All right, for this video, I intend to prove a couple of trig identities. The first is that the cosine of theta equals the cosine of negative theta. All right, so we have our unit circle here, and you know that you start your angle at the positive x-axis, and you head in the counterclockwise direction. So if I were to draw a radius right here, this angle starting from the x-axis headed in that direction is an angle theta. Now the coordinates for this point are the cosine of the angle theta and the sine of the angle theta. So we know that the x-coordinate is the cosine of theta and the y-coordinate is the sine of theta. All right. Theta, of course, is just a Greek letter representing the angle measurement. Now, if you look at the x-coordinate for this point and trace it to the x-axis, the x-coordinate for this point is actually right here. Okay, so that point, we'll just call it x. This point here on the x-axis is the x-coordinate of this point. Now, cosine of theta equals cosine of negative theta. Negative theta means you are traveling in the opposite direction, the clockwise direction. So if we went the same angle in the opposite direction, all right, we went the same amount in the opposite direction and drew in another radius. All right, and we can call this one negative theta. The coordinates for this point would be cosine of negative theta, comma, sine of negative theta. And the x-coordinate for this point, if we traced it to the x-axis, it would be the same x-coordinate as the original angle theta. So if you head in the clockwise direction, just as much as the counterclockwise direction, you will end up at the same x-coordinate, so long as you start from the positive x-axis. Okay, this works on the other side of the circle as well. If I can erase this part here, let's say I started here at the positive x-axis, okay, and I went around counterclockwise 1, 2, about 2.5 quadrants, and I stopped there. Okay, and that would be your angle theta. And I can do the same thing going in the opposite direction. All right, if I started here and went clockwise 2.5 quadrants, that'd be 1, 2.5 quadrants. And I stopped there and I called that one negative theta. And I drew in the radius. Notice if you trace this point to the x-axis, and this point here to the x-axis, it would land on the same x-coordinate, okay? Whether you went positive theta or negative theta, it would land on the same x-coordinate. So this right here is true for all values of theta. All right, now I intend to prove the sine of theta equals the sine of 180 minus theta. Okay, this would be 180 in degrees. If you wanted it in radians, you can say the sine of pi minus theta. Okay, we know pi radians is 180 degrees. Anyhow, once again, on our unit circle, we start at the positive x-axis. Okay, And if you make an angle theta, let's draw the radius first, and you make an angle theta headed in that direction. All right, the coordinates for this point here, we said before, the x is going to be the cosine of theta, and the y coordinate is going to be the sine of theta. All right, so we can trace this point to the y-axis to find the sine of theta. If we traced it to the y-axis, this point right here is the sine of theta. All right. Now, if we were to do sine of 180 minus theta, that means we have to do this same angle starting from 180 and going in the opposite or negative direction. So we said going positive theta is this way, counterclockwise. Negative theta is actually clockwise. So we start at 180. All right, if we go around, this is 90, this is 180. So we're starting at 180. And it's minus theta, so we're going to go this much in the negative direction. So if I could draw in the radius like so, and this angle right here, going in that direction, we can say that's negative theta. All right, but we started at 180, so it's 180 minus theta. So that point right there, if you traced it, we're looking for the y-coordinate. If you traced it to the y-axis, you can see it meets the same point. All right, it's not the same x-coordinate, but it is the same y-coordinate, so it works for sine. So the coordinates for this point, if I can fit this here, this would be cosine of 180 minus theta, comma, sine of 180 minus theta. Okay, I couldn't fit it neatly, but suffice it to say the x-coordinate would not match, but the y-coordinate, sine of theta, matches sine of 180 minus theta. And just like before, you can do this anywhere on the circle. All right, let's say I went about 2.5 quadrants like last time. Start at the positive x-axis and head in this direction. 1, 2, about 2.5 quadrants, or 2.5 times 90. This angle right here would be theta. And now, let's do 180 minus theta. Okay, we're going to start at the negative x-axis and subtract this same amount. So we're going the other way. So about 2.5 quadrants. So starting here, this is 1, 2.5 quadrants. All right. So the one in pink is theta. The angle in black is simply 180 minus theta. And if you look at the y-coordinate of this point, this is the y-axis, so I'm going to trace it to the y-axis. And the y-coordinate of this point here, trace it to the y-axis. The y-coordinate here is going to equal sine of theta, or the sine of 180 minus theta. Okay, same thing. So no matter where you go on this, how many revolutions or how big the angle is on the circle, for the sine or the y-coordinate, the sine of theta will always equal the sine of 180 minus theta.